Hello all, welcome to today's video. Today I'm pretty excited to share an interesting topic in C++. It's related to the memory allocation. We all know that the memory allocation, especially the heap memory allocation, is a pretty costly business. Therefore, it involves a lot of time to allocate a memory in the heap and try to deallocate the same amount of memory. Therefore, it, it is pretty slow when we try to do a heap allocation compared to the stack memory allocation. Therefore, if you want to track how much memory, how much heap memory is getting allocated for our application when it is running, and try to monitor the heap memory usage, there's an easy way to do that in C++. Therefore, this is how I just wanted to share how I used to track my heap allocation in my application. For it is a pretty simple thing. You can actually do it in a pretty simple manner. Therefore, as you can see in the main function, I am using a string object, and I have declared a structure where I'm allocating memory for my structure in the heap using the new operator, and I'm just printing some messages here. For how I track my heap memory allocation in C++ is by overriding or by overloading the new and delete operator. So if you overload this new and delete operator, you will be able to keep track of how much memory is getting allocated in the heap. Either it can be an implicit memory allocation in the case of a string, which is done internally by the string library, or it can be an external memory or explicit memory allocation, like here, where we are explicitly using the new operator to allocate the heap memory. So in both these situations, we can actually get a notification of the memory which is getting allocated in the heap by actually overloading this new operator. Therefore, here, while overloading this new operator, you can define some cout statements to know how much memory is getting allocated in the heap. And just I have defined a static variable which will keep track of how many allocations are made in the heap. So those two things I'm doing in the new operator. I have also overridden, uh, overloaded this delete operator where I am printing the statement how much memory is getting released. You can actually get the size or how much memory is getting released by actually overloading this particular delete function by taking in another size parameter also, where you can get the size information. Normally, generally, if you don't specify size, normally for pointer memory allocation, normally this particular delete will be called. Therefore, so here I am printing this statement. I am decrementing the allocation count. So that's what I'm doing in the new and delete operator. So if you see, if I just run this particular application, let's see what output we get. If I'll just rebuild this particular application and try to run it. So as you can see, the memory gets assigned, 8 bytes of memory gets assigned, and here also 2 times the memory is assigned in the heap uh, for for 8 bytes, and the allocation total allocation count is 2. And after that, one block of memory is getting released, and which decreases the allocation count by 1, and the final allocation count is 1. And after this, the memory which is allocated the memory which is allocated in the heap, that also gets released. This is the final memory allocation which is getting released. So from where these things are coming, let's debug this and find out. Let's put a breakpoint in the new overdone method, overloaded method, uh, and in delete also we'll put a breakpoint. Let's see from where this call comes. When you try to debug it, you will get a breakpoint in the new gets hit. Therefore, let's go to the call stack to see from where it is coming. So as you can see in the from the string library, this particular uh, the new API is getting called, or new operator is getting called to allocate memory in the heap. Therefore, that is pretty evident that this string object allocates memory in the heap. And similarly, if we continue the execution, the second time the new operator method gets hit, overridden methods get hit, and let's see from where it is coming. It is coming from the explicit memory allocation made by our custom structure, custom data structure. For these two items, the memory is getting allocated in the heap, and the size is also we are receiving, which the which we are receiving is the 8 bytes of memory which is getting allocated in the heap. Now let's continue with execution. And as we can see, the first memory which is getting deallocated, uh, it is a pointer which is whose handle is as you can see in the tooltip. For from where it is coming, let's see from the call stack. Let's go to the line number 35. Therefore, from delete my struct, this particular memory deallocation is coming. For let's proceed further, and again this delete is getting hit. Let's see from where it is coming. As you can see, if you go to the main function called stack, it is coming from the end of the main function. Or you can, if you go to the above call stack, you can actually see it is coming from some basic string libraries calling this particular destructor, or the deallocation of the memory is coming from the string library. That is pretty evident that the string library which we are allocating in the initial phase is getting deallocated when the scope of the main function ends. So that is from where the delete overridden method gets called. So that's how this memory allocation and deallocation we can track in our application. So it's pretty easy in this case to track the memory allocation. If you find this particular issue, you just try this thing out in your application, and just to see whether you are getting the memory allocation, just to know how much memory you are allocating in the heap and how much memory deallocation is happening, or just to see if any memory which you are allocating doesn't gets deallocated while the application ends. Therefore, those things you can track it here, and just try this in your application, and just let me know in the comment section whether you are able to see the memory which is getting allocated in the heap or not. And if you find this video helpful, please do like and subscribe this channel, and do share your thoughts in the comment section. Thank you, and have a nice day.